This is the second video in revision of A-level binomial expansions. Students are reminded then that the focus here is on students doing A-level courses in mathematics or equivalent courses, and our intention is not so much to teach binomials as to demonstrate how you can solve typical problems that come up in exams. However, before we do that, we do need to remind you of the key formula that are provided in exams, so you understand what the meaning of each term is in these formula. Now quickly then, what is a binomial expansion? So what we've said is it's when we get something in brackets to an integer power. So like 1 plus x to the power 4, or 2 plus x to the power 6, or here a plus bz to the power 8. Now what we've also recommended in video 1 is that you should always start from a general form, and we're going to use the general form a plus b to the power n, because that means it doesn't matter what you get in the brackets, you will always be able to deal with it. Some people prefer to use a general form which always has a 1 in it, but that doesn't help you if you have something like 2 plus x or a plus bz. So we're going to use a plus b to the power n. Now the background. From the previous video, what we showed is that if you had something like a plus b to the n, you could write it out as a to the n times some coefficient which I've called f1n times a to the n minus 1b plus some coefficient which I've called f2n times a to the n minus 2 b2 plus some coefficient which I've called f3n times a to the n minus 3 b cubed, and so on. And you'll notice the indices here. This 3 corresponds to the fact that I've got an n minus 3 and a b cubed, and so on, and the n corresponds to the power there. Now what we showed in the previous video is that for low n, the coefficients are easy to determine. So if you had a plus b squared, that's your answer, and you can see that f12 is 2. If you had a plus b cubed, that's your answer, and you can see that f13 is 3, f23 is 3. If you did a plus b to the power 4, you can easily show that f14 is 4, f24 is 6, f34 is 4. So that was the previous video. And we also showed in the previous video that the coefficients had a very particular pattern. So you can see f12 is 2. f13 and f23 are 3 and 3. f14, f24 and f34 are 4, 6 and 4. And we showed that there was a particular way that you could calculate these coefficients. Now the other thing to note is, of course, the outer coefficients are always 1. You can see that because I've got a 1 times a to the n and a 1 times b to the n. So we know that the coefficients have a particular pattern, but what we want to do is say, okay, but what if n is very large? How am I going to find out what these coefficients should be? So here's the answer. And you'll notice I've said it can be shown that. I'm not going to prove it, and you won't be expected to prove it in A-levels. That this term here, f1n, is always just n. Now you'll notice this little caveat. Obviously it only applies if n is greater than 0. And we've assumed n's an integer anyway. Next one. If you want to find f2n, which is this coefficient here, then you'll find it's always given by this formula, n times n minus 1 divided by 2. But this formula can only be applied if n is greater than 1. What about f3n? Then you can show that this is always given by this formula here, n times n minus 1 times n minus 2 over 2 times 3. And you can only use this formula if n is greater than 2. So here's the question. Can you see a pattern in these coefficients? Is there a pattern as you go from f1n to f2n and f2n to f3n? If you recognize this pattern, you're more likely to recognize the general form that you will need just in case you need a coefficient for a high power. So this is what we've just done, and the question is, what would you do if you were asked to get a coefficient higher than f3n? Now that doesn't happen very often, it's pretty rare, but the odd occasion it does. So this is the general form that you need. You'll see if you were asked for frn, and obviously that would correspond to a to the n minus r b to the r, okay, just in case you were unsure, then what do you see? You do n minus 1, n minus 2, and you keep going all the way down to n minus r minus 1. And you see that works because, for example, if you set r equal to 2, you can see you did n, then n minus 1, but you don't go down to n minus 2. Now what do you have in the denominator? You see you have 2 times 3 times dot 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 all the way up to times r, and you also have this condition here. This formula only applies if n is greater than r. So that's the general expression that you need. It's a bit of a messy one. So if you're keen, there is a shorthand for these coefficients based on combinatorial formula, and this does come up sometimes on A-levels. So here's the formula that we've said, the general formula for FRN, and you say, golly, that's a bit of a mess. However, it can be shown that this is the same as this formula here, n factorial divided by r factorial times n minus r factorial. Now, a key point here is in exams, you may see this notation here. You can see in the brackets with an n over an r, and these two mean the same thing, so you need to remember this notation just in case it comes up. Now, just in case you're wondering what this notation n factorial r factorial means, then this is what it means. If somebody says n factorial, they mean you multiply n by n minus 1 by n minus 2 all the way down to multiply by 1. So an example, just to clarify, 5 factorial is going to be 5 times 4 times 3 times 2 times 1. Or 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so a summary. This is what we've shown. If somebody asks you for a plus b to the power n, then you can write it as a to the n plus n times a to the n minus 1 times b plus n times n minus 1 over 2, so that's the second coefficient. You can see it's got a very well-defined form, times a to the n minus 2b squared, plus n minus 1, n minus 2 over 6 times a to the n minus 3 and b cubed. And what you will find is that most exam questions will not ask you to go beyond the first 3 to 4 terms in the series. And you see here we've got first term, second term, third term, fourth term. So it's unlikely that you will go beyond those. Occasionally you'll be asked for an arbitrary term, which is the previous slide. So what we're going to do now in the remaining videos is show how to use this formula for problem solving.